Oman, a tourist wonder in the eastern part of Arabia, has much to offer, not least its unique geology, which makes it a true geologist's paradise. We will take you through a journey across Oman, showing you its many geological marvels. Through varying landscapes of mountains, deserts, wadis, coastlines and others. From the highest peak in Oman of Jabal Shams, resting 3 kilometers above sea, we dive down to 3 kilometers below sea in the Sea of Oman, where we will start our journey. Here the collision between two continental plates occurs. Arabia gets consumed below Asia at a rate of 4 centimeters a year. As we head west, we climb the Arabian subcontinent. The sea depth changes from 3,000 meters to 100 meters in a short distance. At the northern tip of Oman, the Sea of Oman meets the Arabian Gulf at the Straits of Hormuz. As Arabia collides with Asia, the mountains of Musandam are sinking below sea at a rate of around 7 millimeters a year. As such, today's fjords are actually old wadis that submerged below the sea. Caves and hills once above sea today make sea life flourish and diverse. The journey continues south. The northern Oman Mountains contain the best exposed oceanic crust in the world. These rocks are known as the Oman or Samail ophiolite. They form sharp and dark peaks. Some 80 million years ago, a large slab of the oceanic crust was emplaced on the northern side of Oman. Wadi al-Jizi reveals most of the story. These sausage-like forms are known as pillow lavas. They form when lava emerges on the seafloor and quickly chills. Not far from here, vertical features known as sheeted dikes represent the original position of the fissure in the rock into which the magma surged. Copper ore was mined since ancient times from Wadi al-Jizi. Current-day mines are present next to ancient mining sites. The weathered dark pebbles of ophiolite covers the area. Near Ibri, this debris emerges through narrow ridges of bounding white limestone as a spectacular fan. The ophiolite was emplaced on Oman along with deep ocean sediments. The best place to examine these sediments is in the Hawasina window. As they were transported from the ocean to Oman, the rocks were highly deformed and folded. Large, pale, exotic rocks, typical of shallow water, were formed above volcanic islands in the ocean. At the mouth of the window, hexagonal columns represent the slow cooling of lava sheets below the seafloor. East of here is Wadi Abyad. 2 different units of the earth can be seen. The upper section is part of the Earth's crust, whereas the lower, darker unit is part of the mantle. The line that separates them is known as the moho, which normally lies 8 kilometers under the ocean floor. Next to the moho, you can see the white water pools formed as the ophiolite naturally traps CO2 from air, converting it to solid soap-like carbonates. Along the contact between the ophiolite and the limestone of Jabal Akhdar lie a number of hot springs, such as Al-Kasfa in Al-Rustaq and Al-Hammam in Muscat. These springs emerge along a fault that separates the two rock masses. As rains fall, water percolates to considerable depths, gets heated, and seeps back to the surface along the fault. Jabal Akhdar Massif separates Al-Batna from Al-Dahliya. The only road that connects the two sides goes through this window. As you drive along the road, you can examine glacial and limestone rocks deposited here more than 550 million years ago. The Snake Canyon of Wadi Bima cuts into these rocks. Trekking the wadi is a great adventure. This area is water-rich. A number of mountain villages can be visited here. Beyond the wadi, you can drive up to Jabal Shams, the highest peak in Oman. The mountains here are formed of thick beds of limestone. As you reach this point, you will be enchanted with a view of the whole geological window. Below is Al-Huta Cave, formed by limestone dissolution. The wadi enters the cave from the top and emerges from the other entrance of the cave. Along the southern contact of Jabal Akhdar with the ophiolite lie a number of water channels. This is the underground channels of Falaj Daris. Along with 4 other falages in Oman, Falaj Daris is registered in the World Heritage List. This falaj is what is termed as a Dawoodi type, which taps into underground water sources at the foot of mountains through underground channels. Deep mother wells are sunk to tap into the source of water, and this is then conveyed to settlements on the plains through underground channels. The Dawoodi Falaj system requires sophisticated engineering and knowledge of the mountain geology. The road from Nizwa to Jabal Akhdar goes through Birkat al-Moz and Wadi Muaydin. Along the road, fish teeth and bones that date back to around 150 million years ago are present. In Saik Plateau, many sea fossils can be identified, including various types of corals, bivalves, and sponges. The view here reveals the whole structure of Jabal Akhdar. This giant fold is more than 30 kilometers across, with glacial rocks forming the core, limestone in the flanks and ophiolite on both sides. The western Al-Hajar is separated from the eastern side by the Samail Gap, which is considered as the only easy access between Muscat and Nizwa cities. This is Jabal Seyhatat. It is deeply eroded and has moon-like landscapes of schist. On its northern flank, the contact between the dark ophiolite rocks from the former oceanic crusts and the limestone of the continental crust is clear. The road to Kantab is placed on the contact line between the two rock masses. During the ophiolite emplacement, the Arabian Plate sank to zones of high pressure and temperature. The rocks at these conditions behave like plastic. These folds in Wadi Mai are a snapshot of this process. Sayhattat is about 70 kilometers by 50 kilometers. On the southern flank of Sayhattat, Wadi Amde exhibits many examples of rippled surfaces that date back to 450 million years ago and resemble wave actions in shallow water. Wadi Amde, along with other wadis in this side of Sayhattat, discharge water into the sea. The most water-rich of these is Wadi Daika, which today holds the largest regional dam capable of storing 100 million cubic meters of water. This is the end of Jabal Sayhattat. The area is covered with white tertiary limestone. Tertiary limestone dissolves easily. In here lies one of the largest caves in the world, Majlis al-Jinn. It is a single chamber measuring 310 meters by 225 meters with a dome ceiling 120 meters high and 3 entrances on the roof. The wadis here combine coastal beauty and inland splendor. Wadi Tiwi is well known for its springs and water pools. This is the end of Al-Hajar Mountains. From Musandam to Ras Al-Had, they extend for 700 kilometers. Below us is Jabal Kahwan. It has the oldest known rocks in Oman that date back to more than 850 million years ago. It is part of the crystalline basement of Arabia. These rocks are cut by darker linear dikes. From here, the landscape will change. The Sharqiya sands appear as an arm muscle from space. The northern edge of the Sharqiya sands is truncated by Wadi Batha. Isolated masses of dunes are present on the other side of the wadi. A single linear dune can be more than 100 kilometers long and 100 meters high. Most of the dunes were formed by a strong southwestern monsoon that occurred before 14,000 years ago. To the south, the sand dunes become smaller, and at the coastline they are cemented hard, probably because of high content of carbonate grains. The bedding indicates wind direction from south to north. To the end of this coastline is Bar al-Hikman Peninsula, a large salt flat with tidal lagoons that attracts different types of birds. It works as a perfect lab to understand carbonates and evaporites deposition. About 20 kilometers off the eastern coast of Bar al-Hikman lies Masira, Oman's largest island, 95 kilometers long north to south. Masira is covered with ophiolite which was emplaced here around 65 million years ago, after the Samail ophiolite. From Masira we fly back west. Al-Hukuf area is Oman's unique natural museum. Over history this area remained high, and therefore it exposes now almost all the chapters of Oman's geological story. Igneous rocks of Arabia's basement, older than 700 million years. Earth's oldest fossils, stromatolites, that were produced by ancient cyanobacteria. Trilobites and their traces from more than 450 million years. Grooves formed by pebbles and boulders carried by glaciers when Oman was close to the South Pole 300 million years ago. Tree trunks and pine fruits formed as Oman raced north to warmer climates around 260 million years ago. Various types of rudists, corals and bivalves, and finally and more recently the preserved rock garden at the southern part of Al Hukuf, sculptured by wind and rain. The southeastern coast of Oman has a limestone plain covered with rubbly sediments. As we approach Al-Shu'aymiyah and Hasik, we see various forms of dripstone formed by dissolved and redeposited minerals from limestone as water flows through it. This is the beginning of the Dhofar Mountains. This chain is composed of three main mountains. The northern one is Jabal Samhan. In the foreground, crystalline rocks outcropped on the low coastal plain. The lines running along the plain are igneous dikes, cutting across older rocks and were formed as magma was forced up through fractures. The crystalline rocks are capped at the crest by limestone. Wind and water erosion casted the flatbeds of the crest. Dhofar Mountains are well watered. A number of big caves and sinkholes form here. Tawiatir sinkhole, known as the Birdwell, is considered one of the largest solvent sinkholes in the world, with a depth more than 200 meters. During summer, southeastern monsoon covers the area with a lush green climate. Wadi Darbat is a magnificent park with waterfalls and lakes. Travertine beds in Wadi Darbat look almost like a man-made dam. At the end of the wadi, the legendary ancient ruins of Horuri, which used to be the harbor for the frankincense shipping. Salalah is situated at the edge of a coastal plain that is bounded at the back by steep mountains. Towards Jabal Qamar, these massive cliffs drop down into the Indian Ocean. The blowholes of Marseille are examples of sea caves that extend to land. To the north, Dhofar Mountains have a gentle slope. A number of wadis flow to the north. Hard, cauliflower-shaped geodes are in here. When cut open, geodes reveal a beautiful interior. At the edge of Rub al-Khali, the sand dunes are large and separated by sabkha because of the sand and water supplies from wind and water. Central Oman is flat. No wadis are formed here. The white area that appears here is a low zone where all the wadis from North Oman terminate. In the western part of this zone exists the Samim sabkha. As wadis flow from mountains, they pick up salt from rocks. The water evaporates, leaving behind the salt it carried, which in turn forms polygonal ridges several meters thick. The central Oman area is also characterized by 6 salt domes, one of which is Karat al-Kabrit. Deep-seated salt is brought to the surface as it pushed the overlying strata to form a dome structure. Erosion of salt leads to the formation of many caves. Some of these are ancient salt mines. To the north of as-Samim is Jabal Fahud. Below it lies the largest oil field in Oman with around 6 billion barrels of oil. Fahud field is developed by Petroleum Development Oman, a company that takes pride in safeguarding Oman's natural heritage while developing its oil resources. This was the end of our journey across Oman through its varied landscapes, displaying a beautiful record of a rich geological history that makes it a true geological wonder.